Have you ever looked out the window at that giant wing and wondered why planes stash all their fuel way out there? Like seriously, out of every spot on the whole aircraft, why shove the gas into the wings? You're sitting there zoning out on that big metal thing, and you probably figure its only job is to keep the plane in the air. But nope, inside those wings is a ridiculous amount of jet fuel, thousands of gallons. So why not just keep it somewhere safer, deeper inside the body of the plane, where it feels more protected? And the simple answer starts with one problem. Planes are thirsty. Planes need a stupid amount of fuel, like way more than most people can expect. A car might have a tank that holds 12 or 15 gallons, maybe 20 if it's a bigger vehicle. A Boeing 747 can carry over 63,000 gallons of fuel, and this much fuel is basically a swimming pool of jet fuel flying through the sky. And jet fuel isn't light either. 1 gallon weighs around 6 to 7 pounds, depending on temperature and fuel type. So when you start doing the math, a fully fueled 747 can take off with well over 350,000 pounds of fuel on board. Just fuel. So engineers had a real problem here. Where do you put that much heavy liquid without messing up the whole aircraft? And if they put giant fuel tanks inside that main body, the plane loses useful space fast. And airlines care a lot about that space. One smaller cargo hold means less freight and fewer paying passengers, and carrying more weight means burning more fuel. So a giant tank inside the fuselage doesn't just take up room, it starts creating other problems. The body needs more reinforcement. The aircraft becomes heavier before it even takes off. Maintenance gets more annoying too, because now fuel systems have to run through areas packed with people, cargo, and important equipment. That's one reason the wings start looking useful. They're huge and also have empty space hidden inside their structure. But that's only the first layer, because if this was only about finding an empty place, engineers could have tried plenty of strange ideas over the years. The real issue is that fuel doesn't behave like luggage. It has weight. It moves. The plane burns it minute by minute. So the aircraft doesn't carry the same weight from takeoff to landing. It keeps changing. And when thousands of gallons start disappearing during a flight, engineers have to deal with a much bigger issue. How do you stop that changing weight from throwing the whole plane off balance? Okay, so this is where center of gravity comes in. Every plane has a balance point. Think of it like balancing a pencil on your finger. Move too much weight toward one end, and the whole thing wants to tip. A plane works the same way, just with way more pressure and a lot more people on board. If it gets too nose heavy, pilots have to fight that. Too tail heavy, and you've got a whole different set of problems. Either way, the plane gets harder to handle. And fuel makes this tricky because it's heavy at takeoff, then it slowly burns off during the flight. So imagine engineers stuck all the fuel in one huge tank near the front of the plane. As the engines burn it, the nose starts losing weight. Now the balance point shifts. Put that giant tank near the back, and the same thing happens in the other direction. Even keeping one massive tank right in the middle doesn't magically fix it, because you still have this huge chunk of liquid weight all sitting in one area. That's why the wings help so much. They spread the fuel out on both sides of the aircraft. So instead of one big lump of weight pulling from a single spot, the fuel sits wider across the plane. As you burn fuel, the weight drops off in a more controlled way. The plane still changes during the flight, of course. Pilots and the flight computers can manage it way more easily. And the cool part is, the wings don't just help with left and right balance. They also place the fuel near one of the most important forces acting on the aircraft. Because once the plane leaves the runway, the wings start doing something that completely changes how all that weight behaves. They create lift. That's the upward force that keeps the aircraft from turning into a very expensive bus. Now, lift doesn't come from the cabin or the tail. The wings do the heavy work. Air flows around them. Pressure changes, and the wings pull the aircraft upward through the air. So when engineers put fuel inside the wings, they place a huge amount of weight close to the same area, creating lift. That matters a lot, because if most of the fuel sat deep inside the body of the plane, the wings would still have to lift that weight from the outside. The aircraft would basically have a heavy middle section hanging between two lifting surfaces. That creates more stress around the parts where the wings connect to the fuselage, and those connection points already deal with brutal forces during flight. Takeoff puts pressure on them. Turbulence adds more. A long flight keeps loading and unloading the structure over and over. So placing fuel inside the wings helps spread the work out a bit. The weight doesn't all sit in the middle like one giant heavy backpack. Some of it sits directly inside the lifting surfaces. That makes the aircraft behave in a smoother, more balanced way. You can think of it like carrying heavy shopping bags. If you carry everything in one hand, your whole body leans and fights it. Spread the weight across both sides, and suddenly walking feels less awkward. A plane has the same kind of problem, just at 35,000 feet, and with a lot more math. So yeah, Wing fuel helps with balance, saves space, and also keeps weight closer to lift. But there is also one more thing. Because the fuel doesn't only sit in the wings. During flight, that fuel actually helps the wings deal with stress. Now it would sound strange, because when you hear put more weight in the wing, your brain goes, wait, isn't that worse? But in the air, the wing has a weird job. Lift pulls the wing upward. The heavy body of the plane pulls downward. So the wing is basically stuck between two forces fighting each other. The outside part of the wing wants to bend up. The fuselage in the middle wants to hang down, and the most stressful area sits right where the wing connects to the body of the aircraft. That area is called the wing root. That's one of the hardest working parts of the whole plane. Now here's the clever bit. When fuel sits inside the wing, it adds weight inside the part that lift keeps trying to push upward. So the fuel pushes down, while lift pulls up. Engineers call this bending relief. In normal human words, the fuel helps stop the wing from flexing too much upward during flight. It kind of acts like a counterweight. The wing still bends, of course. And that leads to another question. If wings hold all this weight, how are they strong enough to act like tanks in the first place? Because aircraft wings aren't just thin sheets of metal. They might look sleek from the outside, but inside there's a lot going on. Engineers build wings with strong internal structures. You've got major support beams running through them. You've got ribs that help keep the shape. You've got panels, sealed sections, fuel lines, pumps, vents, sensors, and small compartments that help control the fuel. So the wing doesn't behave like a hollow box with liquid sloshing around everywhere. It has structure inside. And since the wing already needs strength, engineers take advantage of that. On many aircraft, they don't just place a separate fuel tank inside the wing, like a bottle inside a bag. They seal parts of the wing itself, so it can hold fuel directly. Engineers call this a wet wing, which means the wing structure holds the fuel. The metal skin, the internal sections, the seals, and the support pieces all work together to create the tank. And when engineers divide the wing tank into smaller sections, they can control how the fuel moves around. Because yeah, fuel moves. The plane climbs, turns, descends, hits bumps, changes speed. If engineers just let thousands of gallons slide around freely, that would create a new nightmare. So the wing tank layout helps manage that. Pumps move fuel where it needs to go. Valves control the flow. Internal sections reduce wild movement. Sensors tell the crew and the aircraft systems what's happening. From the passenger seat, none of this feels visible. You just see the wing, maybe a flap moving. But inside that wing, the aircraft constantly manages fuel, like a moving weight system. And there's one more reason engineers don't want fuel tanks sticking out in random places. Airplanes hate drag. Drag is basically the air pushing back against the plane. The more the air fights the aircraft, the more fuel the engines need to burn. So engineers want the aircraft to stay as smooth as possible. The wing already has a carefully shaped surface. Air has to flow around it cleanly, so the aircraft can create lift without wasting energy. If engineers hung large fuel tanks outside the aircraft for normal flights, the airflow would get messier. The plane would deal with extra resistance. Military jets sometimes use external tanks for extra range, but that's a different situation. For a normal passenger aircraft, engineers want the shape clean, so they tuck the fuel inside the wing and keep the outside surface doing its job. But there's still one thing that makes people nervous, because no matter how clever the design sounds, we're still talking about a huge amount of flammable liquid sitting inside the wings of a flying aircraft. So the next question is obvious. Is that actually safe? If engineers pack the fuel into the main body of the plane, now you've got passengers, cargo, electrical systems, and a massive fuel supply, all sharing the same general area. Nobody wants that. With wing tanks, the aircraft keeps the fuel out to the sides, away from the space where people sit. So in a rough landing or emergency, the design doesn't place the biggest fuel load right under everyone's feet. Aircrafts can even dump fuel in an emergency to bring the aircraft down to a safer landing weight. So, engineers built a whole system around fuel in the wings. And once you put all of this together, the wing starts looking very different. It's doing several jobs at once. So the next time you get a window seat and look out at the wing, there's a little hidden story sitting right there. That wing isn't just helping carry you through the sky, it's also carrying the fuel that makes the flight possible. And now I want to know, what's another normal looking thing on a plane that you think has a hidden purpose? Also, if you enjoyed this video, hit like and subscribe for more such smart engineering behind things, and drop a comment with another detail you want explained next.